Welcome to New Focused Approach to Mathematics Basic 9. This is the revised edition, and in this lesson, we want to learn how to apply associative property of addition and multiplication to solve problems. Now, let's start with associative property of addition. I have a number called A plus a number called B plus a number called C. I can do the same thing, A plus B plus C. I've written the same number. Left hand side is the same as the right hand side. Now, if I do A plus B first before plus C, or I do B plus C first before A, if the left hand side becomes the same as the right hand side, since I'm using addition as an operational sign, then we'll say addition is commutative. I have 2 plus 5 plus 3. 2 plus 5 plus 3. I've written the same thing. Nothing has changed, right? Good. Let me add 2 plus 5 here first, and that will give me 7, then plus 3. This time around, let me add 5 plus 3 first. So I'll keep my 2. 5 plus 3 is 8. 7 plus 3 is 10. 2 plus 8 is 10. Since the left-hand side is equal to the right-hand side, my conclusion is that addition is associative. Addition is associative. It's as simple as that, right? Let's take an example. Let's see how we can apply this. But before we do that, can this same thing work for subtraction? Okay, if I have 2 minus 3 minus 4, 2 minus 3 minus 4, I've written the same thing. So ideally, in simplifying, the left-hand side should be equal to the right-hand side. Okay, so in the course of doing it, let me try to start with 2 minus 3. And 2 minus 3, I know that is going to give me negative 1. Then I bring minus 4. What about the right-hand side? This time around, I want to do this one rather first. So I have my 2 minus into bracket. This and this will give me, that is 3 minus 4 will give me negative 1. Now, I have negative 1 minus 4. That is negative 5. I have 2 minus negative 1, and that will give me 3. So you can see that the left-hand side is not equal to the right-hand side. The conclusion is that subtraction is not commutative. Even though I wrote the same thing at the left-hand side and the right-hand side, but after the computation, the results are not the same. It means that subtraction is not associative. Now, how can we apply this to solve questions? That is addition of commutative, so associative property of addition. Let's say I have these numbers to sum, okay, or to add. So I'm going to do 37 plus 50 plus 13. If I know my associative property very well, I rather prefer doing 37 plus 13 then plus 50, which will make the work very easy, because with this I can add 10 plus 3, and 1 plus 3, that will give me 4. Then this and this will give me 10, and so I'm going to get the answer to be 50. Then plus the 50 here, okay, and that will give me easily 100. But if I add this to this before adding this, it will be a bit difficult, but I can rearrange it and get the same answer, right? Then again, let's look at 19 plus 38 plus 11. With the help of associative property, I'll do 19 plus 11 then plus 38. And of course, 19 plus 11, because of the 9 and then the 1, it will be very easy for me to do that addition. And so I'm going to get 30 for this one, then plus 38. Of course, if I'm adding 30 and 38, what I'm going to do is that I'm just adding 30 plus 30 is 60, then add 8 and get 38, and that becomes the answer. Finally, if I'm to do this plus this, I'll do the arrangement 78 plus 22, then plus 49. So I can do this one first because I can add 20 plus 70 and that will give me 90. Then 2 plus that will give me 10. So I can have 100 here plus 49. And 100 plus 49 is easier to add compared to arranging this same question as 78 plus 49 plus 11. When I'm doing this first before the 11, it will be a bit, 78, 49, and 22. If I'm doing 78 plus 49, because of the carrying, it's a bit complicated than rather doing 78 plus 22 before adding the 49, which of course will give us 149. So this is how we can apply associative property in solving questions. Again, let's look at associative property of multiplication. If I have 2 times 3 times 4, I'm going to write the same thing, 2 times 3 times 4. So I've written the same thing. They are the same. Now, in the course of multiplying, let me multiply this one first, which of course I'm going to have 6 times 4. At the other side, let me multiply this one rather first. So 2 times into bracket 12. That is 3 times 4. 6 times 4, I know is 24. 12 times 2 times 12, I know is 24. And so since the left-hand side is equal to the right-hand side, we'll say multiplication is associative. Multiplication is associative. In the case of division, check this. If I say I have 10 divided by 2 divided by 3, 10 divided by 2 divided by 3, based on what I did with multiplication, the left-hand side should be equal to the right-hand side because I've written the same thing at both sides. But how come when I do the division, 10 divided by 2 is 5, 10 divided by 3. Here I'll keep the 10 and then do the side here first. 2 divided by 3 is 0.66666, but I can say 0.67. Maybe let's leave it like that. Now, 5 divided by 3 will also give us a repeating decimal of 1.66666, or let's say 1.667 or something. Then we have 10 divided by 0.6 is going to give us 14.925, which is not equal to the first one. So the conclusion is that division is not associative. Division is not associative. Now, how do we apply this concept of associative property to multiply numbers? So I say I have 12 times 15 times 5. I can multiply this first before times 5, or I can multiply this before times that. But to me, it will be easier. I'll multiply 12 times 5, then I multiply times 15. And this is the reason. I know how to multiply a number by 5 with ease. So 5 times 12 times 5 is going to give me 60 because I divide here by 2, I add 0. Then times 15. And 60 times 15 also can be done easily because I'll do 60 times 10, then I'll do 60 times 5 and put them together, right? And that is very simple. You're going to get 600 and 300, and then together we can write 900, and that becomes so easy to do. Now the same thing we can do for 14, 30, and 5. Do 14 times 5, which will give you 70, and 70 times 30. And 70 times 30 is very easy because 7 times 3 is 21. Then you attach your 0. Okay? So like I said, while this one is giving you 70, this one is giving you 30 as well. So 7 times 3 we know is 21. Then we bring our 2 zeros to give us 2,100. Now, use the same idea to solve this one and see how it will go. I'm sure you've learned a lot from this lesson. Thanks so much for watching.